All right, I think everyone's connected, Ritvick, whenever you're ready.
All right. Hello, everyone. My name is Ritvick. I'm the tech advisor at ICP Hub North America. It's one of the hub which is tasked to promote and educate the North American market with Internet Computer Protocol. That's a layer one blockchain and how it is different from other blockchains. I'll also give Javier you the floor just to quickly introduce yourself.
Yeah, thank you, Ritvick. Hello everyone. My name is Javier Arroyo. I'm the co-founder and the manager here in the ICP Hub Canada and the US. We are doing a lot of different activities related with education, hackathons, workshops, boot camps. Also, we have the ICP Master that we are trying as well to educate people in different programming languages. We use in Internet Computer WebAssembly. It means you can build in TypeScript, Python, Rust, and also in Motoko, that is our own programming language, similar to Solidity for Ethereum. We use Motoko. It's a pleasure to collaborate with UCLA, with Alex. That is amazing. And thank you everyone for your time today. I hope you learn a lot about the blockchain, about Internet Computer. And thank you everyone. Over to you, Ritvick. Thanks for the opportunity.
Perfect. So let's try to make this session a bit interactive. So feel free to ask me any questions. Feel free to interrupt me or even post questions in the chat. I'll have a look at it and then I can answer your questions in the real time itself. So let's get started. Alex, I'm not sure. Can you give me the screen sharing permission as well?
Did it work, Ritvick?
No, it says host disabled participant screen sharing.
Give me 1 second.
I think you have to log in Zoom, Alex. And then once you are in Zoom, you can be able to give the permission to read it.
All right, so now I have it. Let me know if you guys can see my screen.
Everyone can see your screen because you're being projected on 2 huge TVs. I think they're what, like 72 inches or something.
Perfect. All right, so let's get started. So how many of you already know about Internet Computer or even Bitcoin and Ethereum, or have any idea how it is different? Anybody can answer this or type your answers in chat. Feel free to interact.
Alex just taught us a little bit about it in class today. So it's decentralized computing, similar to AWS if you wanted to rent some computing power.
That's correct. So let's take a step back. Let's go into 2008 and see what Bitcoin has done. Bitcoin has given us a decentralized money with the ability to move Bitcoins from address A to address B. And that's a transfer of value from address A to address B, right? It's just a ledger. every miner on Bitcoin network has a copy of this ledger. So that way, everybody verifies what is happening when A sends to B and B sends to C and so on. Now with the evolution, people saw if we can, have a decentralized money with cryptography, why can't we have decentralized softwares? And that's where Ethereum came into picture around 2015, where apart from just the money movement, they also gave the capability of executing programs on the blockchain itself. What this gave us is basically now you can compute on the Ethereum blockchain as well, apart from just sending money. One of the classic example is Uniswap, which is a decentralized application built on Ethereum. And now you can trade Ethereum with other tokens and other securities completely on chain. And that particular smart contract, since it is deployed on Ethereum and guarded by a lot of miners across the globe, it's unstoppable. No government, not even single entity, even the owners of Uniswap can't stop the whole execution of the exchange. So these two evolutions were very critical in the history of blockchains, but it came with a lot of baggage of problems as well. So now we understand what were the problems with Bitcoin. There was no programming capability available on that chain. With Ethereum, again, the problem was it was based on proof of work. That was one problem which is solved now. The other problem was the ability to scale for a Web2 like adoption. Imagine you want to run a total NASDAQ and Toronto Exchange and all these the global finance on Ethereum. That is not scalable on that particular chain because it has a limit. So going from proof of work, which was just verifying transactions by solving a random mathematical problem, and whoever solves that problem first is the winner to add a block to the whole blockchain. Ethereum migrated from proof of work to proof of stake, where they chose only a few validators will be verifying the network. So there is not much need of solving of the complex mathematical problem. But at the same time, they introduced the concept of proof of staking, where the Ethereum holders can basically choose who the validator will be. And the biggest challenge which it poses to the industry is that around 40% of the validators on Ethereum chain are just out of United States. So imagine what if that number grows beyond 50 to 60%, and the government can literally step in and can basically control or regulate the whole Ethereum network itself. Going through all these problems, then came the evolution of internet computer, and we call it basically the world computer. And you'll see in our slides further why internet computers is a revolution in the evolution of blockchain technologies itself. So just to lay a background here, what internet computer is, think about of AWS that gives you a cloud hosting infrastructure where you could basically store enormous amount of data. You can compute enormous amount of data, and then there is always a network access between your client computer and the cloud providers, right? And then there are these 2 or 3 monopolistic, huge enterprise savvy cloud providers in our world today, namely AWS, GCP, Microsoft Azure, and then there are a few more by other providers like Oracle and such. Now, these providers do a lot of provide, lot of services on top of it. You call it IaaS, EaaS, software as a service, and the pricing is totally monopolistic. So as they see adoption of certain services on their platform, they are in control of moving the pricing and charging their customers based on whatever they need. And that's where internet computer came into picture, where they tried to basically merge both the cloud infrastructure as well as all the functionalities of a layer 1 blockchain. So in the nutshell, the internet computer is a decentralized cloud with all the functionalities of a layer 1 blockchain. So today we'll go through what all features and differentiating factors the internet computer blockchain provides and how it is different from Bitcoin, Ethereum, Solana, Cardano, all the layer 1 blockchains in the market who are trying to solve the problems of Bitcoin and Ethereum in the end, and potentially want to become ETH killer at some point. You guys would have heard in the industry that Solana is projecting themselves as becoming an ETH killer because they have solved the problem of scalability, but then still certain problems are still there, which we'll probably discuss in our today's presentation. So this is just a table of content we'll go through. We'll go through the unique features of internet computer. We'll see how an end-to-end user experience look like on the IC network, what internet identity is. Internet identity is something very similar to MetaMask for Ethereum, or a hardware wallet or a software wallet for Bitcoin. It allows user to identify as an identity on the ICP protocol. Then we'll talk about the ICP token itself, what role it plays in the governance. Then we'll go on to what DAOs are, how ICP is the first layer 1 blockchain which has the DAO framework built into the protocol itself, and a couple of other features as Alex mentioned in the beginning, the native integration of Bitcoin and Ethereum. So let's dive deep into this. So internet computer has a novel consensus mechanism. By this, what we mean is, unlike Bitcoin, where we are doing a lot of complex mathematical calculations just to be the one who can add block to the whole layer 1 blockchain, on internet computer, the network is provided by industry grade servers sitting in tier 3, tier 4 data centers, thus ensuring high availability as well as high amount of compute. And these node machines, which are responsible for executing the compute and storing the data, they are different from the governance side. To set you an example here, when we talked about Ethereum blockchain, where a validator node is basically chosen by the community based on how many Ethereum are staked on that particular blockchain, the same validator node is also validating the block. On internet computer, these two are totally different cases. Governance is handled separately, and the useful work, the actual computation, is happening separately. So that way, there is not many unnecessary work which is being done on the internet computer blockchain, and people who deploy their smart contracts, the people who basically store data, only use the infrastructure for that particular purpose itself. Now, coming to the second part is, since the node machines are in the data center environment, they have 99.99% availability on network, the data consumption, the electricity, and these node machines are itself very powerful in nature, right? So these are the cutting edge hardware which is right now being sold to these enterprise grade data centers. So we haven't seen any significant downtime since the launch of the internet computer blockchain, and it has been more than 2.5 years now. ICP is also one of the greenest blockchain, and a good way to compare that is basically the amount of energy which is wasted when you do a Google search. That's twice in comparison to executing just a single transaction on the ICP chain. And later on, I'll show you the dashboard where you can basically visualize how the network of the internet computer looks like. But you can there actually go and verify how much electricity a internet computer, the server machine, the node machine, is actually consuming. And that's where we got this into the greenest blockchain certification, where it is proved that the amount of energy being wasted on a transaction is much significantly less, even in comparison with the enterprise cloud. And the beauty about smart contracts on the ICP blockchain is it completely differentiates itself from the Ethereum smart contracts or any other blockchain smart contracts. To give an example, all these layer 1 blockchains in the market right now, you consider it whether it be Ethereum, Solana, Cardano, Aptos, Tron, all these are ledger-based technologies. What does it mean is you can basically see, the smart contract which is written and the input and output it is doing, that is stored on a public ledger which is copied across every machine basically. So for example, if you have to store a video or a digital image on Ethereum blockchain, you can't even store it. It will cost you thousands and thousands of dollars because that ledger is very expensive by the nature it is designed. On internet computer, since these smart contracts are powered by these massive servers, you have the capability to store massive amount of data within a smart contract on internet computer blockchain itself. So that gives you the ability to build probably an application like YouTube, application like TikTok, Facebook, and whatever, on which you can even store, digital media and high amount of data directly on chain itself. Any questions so far?
Yeah.
Yep. Can you unmute and speak?
Oh, thank you. Hello, do you hear me?
Yes.
Oh, can you explain a little more of the relationship between the servers and the ICPs? So is the video or the media or the web page located on the blockchains, or are they located on servers and they are paid by smart contracts? I don't really quite understand.
Can you hear me? Yeah. So basically, these servers basically power the blockchain itself. So comparing it with Ethereum, where there are these validator nodes, which are a standard VM, which executes these transactions, the servers on the internet computer blockchain form the essential network itself. So to give you an example, let me share this screen here quickly. Let me know if you can see my screen. So this is the dashboard of the internet computer blockchain itself. And you see all these big blue circles. These are essentially a set of servers deployed in that particular geographical location inside a rack in a data center. Now, what happens is one of the servers is chosen from a particular data center, and that forms a subnet on the internet computer blockchain. So you could think of internet computer as a combination of many, many blockchains, right? And these servers, which form part of the blockchain, belongs to each and individual countries based on Satoshi Nakamoto coefficient to decentralize the network further. Now, when I say you can store digital images and videos on the blockchain itself, that means once you store it on the blockchain network, that data will be replicated to all the servers which are part of the network across the geographical location. So there is around 20 to 25 times of replication available for the same data. So even let's say if the internet line between the North American continent and the rest of the world breaks down, the network will still function, and the amount of data which you had stored will stay intact on the particular blockchain. Does that answer your question, Lewis?
Yes, thank you.
All right, so let's move forward. Now, the other set of features is basically the transaction cost. So as you can see, in order to move a Bitcoin, you might get charged 0.001 Bitcoin, but since the price of Bitcoin is huge, it's a large amount of money which you basically spend just to basically send amount from wallet A to wallet B. Same cases on Ethereum. The cost is not low. To give you a classic example, in 2021, when Uniswap came into picture and not many people were trading NFTs and tokens on the Uniswap exchange, in order to just execute one transaction on the Ethereum blockchain, people were spending around $50 to $150, and that was a huge pain in the adoption of the Ethereum blockchain itself. And that's where today we see Solana, Cardano, everybody fighting to solve the cost problems. And essentially, these are the scaling problems which existed on the Ethereum blockchain. On ICP, the cost to execute a transaction is negligibly small, basically. So as you can see, it's around 0.3 zeros and 1 ICP on the blockchain. ICP is $15 right now. So that's negligibly less when it comes to execute transactions and do some amount of compute on the internet computer blockchain. The other differentiating factor is the reverse gas model. I'm not sure how many of you have tried interacting with any of the blockchains in the market. Whenever you do interact with them, what happens is basically to make a transaction on particular blockchain, you have to pay a fee basically. And fee is basically based on the amount of load the network is currently having and the amount of users who are trying to interact with the blockchain. On internet computer, the fees is already paid by the developer of the application. So as a user, you don't have any burden if you have to interact with the blockchain, you have to send a transaction or you have to sign a transaction. So that's the reverse gas model. And this is a very good point from a perspective of the adoption of a blockchain technology. Now, since we already touched the concept of storing data on the internet computer blockchain, it hardly costs you $5 to store a 1 gigabyte of data for a year on chain. And don't forget the aspect of the complete replication of that data. That is also not given to you for free by enterprise clouds like AWS and GCP. And not to mention, this is millions and millions times cheaper than Ethereum, because Ethereum is a ledger-based technology. Even to store a kilobyte or multiple kilobytes of data, it's a costly affair on the Ethereum blockchain. And one of the differentiating factors, which is baked into the ICP protocol itself, is the ability to interact with the Web2 world. So imagine you have a smart contract deployed on the internet computer blockchain, and you want to consume some data from our traditional world. For example, you want to consume the weather data, you want to consume an IoT data, or you want to consume some sort of financial data. If you have to do something like that on the Ethereum blockchain, that is completely not doable. What you'll have to do as a workaround to that situation is you'll have to basically probably use a other chain which call themselves as an oracle to the Web3 world, which is Chainlink is one of the chain, and you have to have an integration in your front end basically. So front end which is not relying on the Ethereum blockchain, which is living probably on a CDN in the centralized cloud, will be talking to Chainlink to do all these negotiations of getting data, the weather data, the stock data, or whatever on the front end. And then the smart contracts essentially will trust the front end. Hey, what you are sending is correct. They don't have any capability to see what is happening in the Web2 world. Whereas on the ICP blockchain, the smart contracts which are deployed on the ICP blockchain, they can themselves make a Web2 REST API call to consume that data. And since these smart contracts are executed across all the node machines we just saw on the planet, different data centers, they all will call that API and then reach to a consensus. Now, hey, okay, this is the data we are getting regarding the temperature in California. We agree to a consensus, and that's how we make it visible to the smart contract to be consumed for any application. So this is a very, very big differentiating factor from the other blockchains existing in the market. Any questions so far? No, I think we can move forward. Let's talk about an end-to-end experience, the on-chain experience on the internet computer blockchain. So now we talked about Uniswap a little bit before. Pretty cool, right? We have a decentralized smart contract, unstoppable exchange, no government can stop it. That's fine. But what about the user interface, the HTML code and the CSS code where user is interacting by a few mouse click, and that front end is facilitating authentication via MetaMask wallet and then interacting with the smart contracts in the background? That front end is deployed on a CDN. That front end is under the control of a developer. What if somebody goes rogue in the Uniswap exchange, a developer who maintains that code? Someday they can make something fishy, deploy it, and then millions of users will get compromised, right? Or apart from that, imagine a government tomorrow says, hey, this trading of this security is completely illegal in the United States. Why don't we shut down? And they'll directly talk to AWS to shut down the front-end rendering website. Though there is capability, the front end is open source, so any tech-savvy person can definitely go clone the GitHub repository, spin up the front end on their own. But majority of the Web3 users and more who are transitioning from Web2 to Web3, they don't have this capability. And this is a classic limitation of any layer 1 blockchain in the ecosystem we have, whether it be Solana, Cardano, Ethereum, any layer 2 like Polygon, Matic, and whatever. On internet computer, the beauty is you can store the entire front end within a smart contract. So imagine a specialized smart contract which can store front end HTML, CSS, JavaScript files. And also that smart contract has a mini Apache or Nginx server so that it understands our Web2 today. So you can make an HTTP call to that particular smart contract. And that smart contract is immutable in nature. So essentially, You can host a front end on the internet computer blockchain itself, as well as the backend. So the complete full stack application can be deployed to IC chain. And thus, then you have the capability of having an immutable decentralized application living on internet computer flow forever, and nobody has the ability to basically stop it. So this I already talked about. And the good part is ICP as a blockchain is also recognized by major search engines like Google and Bing. So if you have a front end deployed on the internet computer, Google crawlers will come and scan your website and happily index those websites as well. So you don't have to, worry about marketing your own product, figuring out like how people will know about it. And this is very different from Ethereum smart contracts. Google crawlers do not know where the Ethereum smart contracts reside, what their structure is, how to understand. So this gives a leading edge to a world computer like this, where it is easily searchable by our traditional internet itself. Let's quickly jump on to internet identity. It's very similar to MetaMask, but why internet identity? In comparison with other chains like Ethereum, Solana, and whatever, the identity is basically essentially a pair of public and private keys, right? And essentially you store it within a secure vault within your computer. Somehow Chrome gives access that to your browser extension, and the identity is essentially in the browser extension itself. Now, on internet computer, the identity is stored on the protocol itself. So you don't necessarily need a third-party wallet to interact with internet computer blockchain and worry about carrying on this wallet with you, configuring MetaMask and whatever. Through a UI browser, you can directly go onto internet identity and start an internet identity, right? And this identity will help you to interact with multiple dApps which are deployed on the internet computer blockchain itself. One of the critical features which is not covered in this slide is, let's say, for example, on Ethereum blockchain, you use MetaMask wallet to trade on Uniswap. You also use the same wallet to interact with a gaming application. You also use the same wallet to transfer some funds to your friend. The problem is anybody can basically trace the behavior, how a wallet is doing on the Ethereum blockchain. They know, okay, this particular wallet is transacting with Uniswap as well, sending funds here and there as well. So whatever dApps those wallets will touch, there is a traceability happening, and that compromises your identity and security to a certain extent as well. Whereas on the internet computer, when you create an identity, that's an identity which is very, very private to yourself. And when you use that identity to interact with, let's say, dApp A or dApp B, dApp A will see you as a different identity and dApp B will see you as a different identity. So for example, your identity is 1. When you'll be interacting with A might see you as a user with ID 99. And when you interact with B might see you as a user with ID 53. And that way there is no tracing of a particular user or particular identity, what they are doing on the internet computer blockchain. Just a level of privacy and security on top of what we already had existing in the layer 1 blockchains. Any questions so far? Feel free to put in the chat or ask me here. All right, let's move forward. Now let's talk about the governance and the ICP token itself. So the ICP token is a utility token which can be used in many ways. One of the way to use ICP is basically in the governance itself. So as you know, Internet Computer Protocol is a decentralized blockchain. Even the governance, like what will happen, what kind of development ICP protocol should prioritize, that is decentralized too. So anybody can come in, put in a proposal, hey, I see this feature as being very critical to ICP. You float that proposal, and then whoever holds the ICP will essentially vote on top of it. And this governance is very similar to other available blockchains as well. So you can use your ICP token to participate in the governance on the Internet Computer Protocol itself. Second thing is obviously payments, right? So we haven't gone and changed the use case of what Bitcoin gave us. ICP can still be used as, as a transfer of value between two persons. ICP is also used to power compute on the internet computer blockchain. So let's say if you deploy a smart contract, and as a developer, as we have seen reverse gas model, we have to basically provision the amount of compute and storage within that smart contract itself. How do you pay for it? You are not going to use your Visa, credit card, or debit card, right? So the amount of compute on the internet computer blockchain, very similar to gas fees on Ethereum, where user pays it. Here developers pay the gas fee and we call it cycles. And the only way to power compute is to burn the ICP token and get that compute. And this is only one way. You cannot reverse it. You cannot again convert your compute which you have bought to ICP again. This makes internet computer a deflationary blockchain as well. The more the amount of compute and the usage of the blockchain will happen, the ICP will get burnt and get out of the circulation. And the more the amount of adoption will happen, since ICP will diminish, as Alex was mentioning, right? Bitcoin cuts half every 4 years, but on ICP, it completely depends on usage, right? So as usage goes, ICP goes down, and hence it will have a positive impact on the price. ICP can also be used to invest in decentralized autonomous organizations, and it's a very critical feature. We'll just talk about it. But then people can use ICP to become very, very early investors to a lot of projects which are spinning up day and night on the internet computer blockchain. Now there is a video how to stake ICPs and then participate in the governance process. I leave this as out of scope for now. If anybody is interested, they can go and just Google search it. How can I stake ICP on Google search, and you'll get a video or multiple resources around it. Let's talk about DAO on the ICP network, and we call it a framework. It's a service nervous system framework. What ICP provide you is basically, it gives you a protocol level infrastructure where anybody could basically spin up a DAO. So very similar to, let's say, if you have to register a company and open a company in the traditional world, you'll go to the government of United States or government of California. You'll say, hey, this is my company name. I want to open a company. You basically open a company. And then you go to basically private investors to basically pitch your idea, get some funding, build the product. If the product is great, there is good product market fit, essentially you'll go via a acquisition route or might go via an IPO route. But that's the way of a traditional company, right? Whereas for a DAO, since it's a decentralized organization, you want governance of that particular company to happen from day one. So let's say 2 or 3 founders want to open a company, but they want to open a decentralized company. They can come onto ICP chain, they can put in their name and all the registration process. There is a very concise checklist, and then you can open a DAO. Now to get some funds, you'll not go to private investors. You can directly go to the community to raise funds for your DAO, and everything happens in a transparent manner. So whatever DAO is doing, that is publicly visible on the dashboard. Any proposal you pass, any decision you make, and the early supporters of the DAO, people who will basically invest money using ICP in your DAO, they will get the DAO token. And that DAO token will essentially be used for the governance of that particular decentralized application. We had a very good success of OpenChat. OpenChat is a decentralized chat protocol, very similar to WhatsApp, but it's completely private, decentralized. It is also very secure than Signal and Telegram. So let's say person A want to talk to person B. They are talking via a smart contract deployed on the internet computer blockchain. And nobody sees what the talking is happening because the state or the data stored inside the smart contract, it is private in comparison with the ledger-based technologies, right? So this particular application, OpenChat, went via the DAO route. They were a decentralized autonomous organization from day one, and they closed a funding of $5 million in just 6 hours. And this is a typical tokenomics, how it looks like, where there are various components of for the founding team, for the early investors, for the community, and then there is a reserve treasury, how you can use your token in the future to sustain the development of your project itself. You guys can basically go ahead and search on Google the OpenChat DAO, and you'll find many, many resources on top of it. And similar to OpenChat, there are many, many applications on the internet computer blockchain already live So think about any traditional application, whether it be YouTube, Reddit, GoDaddy, Twitter. There is an analogous on the internet computer blockchain. How it differentiates from the traditional world? No government can stop it. Even if the founding team doesn't exist, since it's a DAO, the development can continue, and community is the owner of these particular applications. And whatever happens, the development happening in these applications, what these applications are doing, it is completely transparent as it is deployed on the ICP blockchain. Now, you might be interested, how do I build an application of internet computer? And you are very, very lucky. Unlike Ethereum and Aptos, you don't have to learn just their own proprietary language. We do have our proprietary language. It's Motoko. It's more flexible, more feature-rich, but you can also use other programming languages like Rust, TypeScript, and Python to code a smart contract on internet computers. So your learning curve is very, very less. Since you'll be coding your most of the front end in JavaScript, TypeScript is just a typing wrapper on top of it. Anybody can quickly learn and deploy smart contracts on the internet computer blockchain itself. If you guys would want to know more about how to build applications, there is a very good tutorial available. So just go to docs.internetcomputer.org, and then you can basically, pick up a language of your reference. And this is the website where you would basically want to start whenever you decide to create a internet computer dApp on the ICP chain itself. And then there are forums like Stack Overflow. If you want to ask any questions, feel free to join the developer forums and Discord channels. I'll forward the slide to Alex. He can forward it to you. That way you'll get into the ecosystem. And if you have any questions, you can ask there. The community is very, very helpful. Even the developers from the foundation also do spend a lot of time there to answer any queries developers might have. Let's quickly touch base regarding the support. Let's say if you're a passionate developer would want to build on the ICP ecosystem, there is a huge grant program up and running. So you can apply for a grant with your innovative idea. And if it gets selected, you get funding to basically develop on the ICP chain. And you do not have to give any equity or anything. It's just a grant application, one-way money. You can use it to fund your development and to market your project. For people who are not developers, who are more into content creation or ecosystem building, they can apply for community grants, and it also works very similar to developer grants. Any questions so far, guys?
I think we have 2 questions on the chat.
All right, so the first question is wondering how a decentralized network can handle misinformation. It seems to me that a centralized governance can control sensitive information shared so that it does not negatively impact. Perfect. So for example, if you want to, have a facility to prevent the misinformation, the key component is basically you have moderators within the DAO itself. So these moderators will essentially, vote to basically flag the misinformed content, and this can be built into the dApp itself to an extent where you could incentivize those moderators on a function, how that money can basically transition from the amount of raised by the DAO or your DAO treasury itself. So people who are moderating, they can be incentivized, and the moderation can also happen based on consensus, right? So you define a mathematical formula, whatever suits the application itself. And if enough person votes on flagging the content, the protocol basically can take it down. And developers are completely free to develop their moderation algorithms, to develop their incentivization algorithms directly within their smart contract itself. Does that answer your question?
Yes, it does. Thank you.
Perfect. And Louis again asked, should a user must pay with ICP to use the internet computer and web browsing, or it's only the developers of the apps and the webs? So basically, most of the applications, developers pre-fund with all the compute and the storage which is needed to empower a smart contract, whether it be front end, back end, and whatever. So let's say if a lame user is coming to your particular product, it's not necessary you have to charge them. Basically, it's completely free. They'll just open the website like they're opening google.com and they're not charged. But let's say if you want to charge users, you can build those functions within your application. So for example, you can have a freemium version within your application itself, right? So certain features are completely free, and other features you can definitely charge users if you want to. Let's move on to the chain key cryptography and native Bitcoin integration and why it is very, very critical. I'm not sure how many of you are aware what bridges do, but to give you an example, imagine you have to trade Bitcoin against Ethereum on Uniswap exchange, which is a decentralized exchange on Ethereum. You cannot use real Bitcoin, not at all, because Ethereum doesn't understand. Ethereum only understands ERC20 standard tokens or ERC721 NFT tokens, which is built on the Ethereum chain. So what do you do to use Bitcoin on the Ethereum chain? What you can do probably is go to Binance, give your Bitcoin to Binance or Coinbase or these centralized exchanges, and then get a wrapped version of the Bitcoin. And this wrapped version is an ERC720 token or ERC20 token, which can then be understood by the Ethereum blockchain. But the negative part is, imagine tomorrow Coinbase doesn't exist. SEC, shuts down Coinbase, and something bad happens with CZ at Binance. Where you'll go again to convert that wrapped Bitcoin into the real Bitcoin? And imagine how many different blockchains you'll be able to use in this particular fashion, where you have to get a wrapped version from a centralized entity. So that's where Internet Computer have a direct Bitcoin integration within the protocol itself. To explain to you this in layman terms, what happens is, so these smart contracts, since they can store private data, so they can also hold private keys of a real Bitcoin wallet. So imagine you can design a very smart contract itself, which can make calls to Ethereum blockchain or Bitcoin blockchain and order a Bitcoin chain to move the Bitcoin from address A to address B. And this will happen in a completely decentralized manner, because these smart contracts, which are ordering Bitcoin blockchain to move the funds, are ultimately executing on the Internet Computer blockchain itself. Another use case is, for example, there is an exchange on the Internet Computer blockchain itself. If you want to trade ICP or any other native tokens with the Bitcoin, you do not have to go to any centralized exchange. You can directly come, send your Bitcoin to these exchanges, and then you can use that Bitcoin to trade against other native tokens and whatever functionality you want to make. This is a very, very cool feature for projects who want to charge their users with real Bitcoin. Imagine you have a gaming project and you have in-game assets, and you want to have some functionality baked in where people can only buy those assets using real Bitcoin. Then it can be achieved on the Internet Computer blockchain, because ICP smart contracts understand what Bitcoin is, how do I move the money on the Bitcoin ledger, how do I verify the money movement has taken place, essentially. So now, since we have the Bitcoin integration, what ICP has done is they have also came up with their own version of Bitcoin, which is CKBTC. And this is pegged exactly one-to-one with the real Bitcoin itself. Now you would ask, hey, Ritvick, now we have the ability, like we can call the Bitcoin chain and we can move real Bitcoin there. Why do we need CKBTC? The real reason is solving the pain point what real BTC is facing. To move funds, it costs you a lot. So for example, you just bring your Bitcoin one time to the Internet Computer blockchain and you get a CKBTC for it. Now you can use send CKBTC, use CKBTC many times on the ICP chain. The costing now will be equivalent to a transaction costing on the ICP itself, which was 0.3 times 0 and 1. So you're able to move CKBTC between multiple wallets at a very, very negligible cost. And then ultimately, when you want to settle it back, you settle it back basically. So you enhance the ability of Bitcoin by giving it power to be transacted many, many times for a fraction amount of cost. And that's CKBTC. And there is no fear of, exchanging BTC to CKBTC or CKBTC to BTC, because this is all happening at the protocol level. You do not have to go to any centralized exchange and rely on them to exchange BTC to CKBTC. You can directly send some BTC to the smart contracts deployed on the IC network, and they'll give back to you the CKBTC. And that particular piece of code is completely running on the ICP blockchain itself, completely decentralized, completely immutable, and hence unstoppable for the eternity. Now we also have Ethereum integration coming up, and this will be very, very huge because that gives you ability to interact with whatever Ethereum smart contracts exist or whatever tokens exist on the Ethereum blockchain, whether it be Chainlink. Chainlink is an Ethereum token, Uniswap is an Ethereum token, and then there are many, many gaming coins like Axie Infinity and whatnot. You'll be able to interact with all those tokens, all the smart contracts on Ethereum directly via a smart contract deployed on the internet computer blockchain itself. Any questions so far, guys? No? Okay, let's try to wrap it up quickly. So what industry is talking about ICP? ICP has grown massively in terms of the developer adoption. There are not many developers contributing to the ecosystem, and it's increasing at ever pace, basically. We have been featured in multiple blockchain reports as well. And you can basically Google it around, how the adoption of ICP is being driven in the community. Few of the governments across the planets are also recognizing the ability of the ICP protocol. So you'll see federal Italy, it's a certification program run by the government. It's a not-for-profit organization, but they are, verifying their products by a digital certificate issued on the ICP chain itself. Let's talk about the foundation. ICP is a decentralized protocol, but Definitive Foundation is a major stakeholder, maintainer, and developer of the protocol itself. And there are many contributors in the ICP ecosystem. The foundation itself consists of many PhD developers, researchers who have been researching this technology since the inception of Ethereum, since 2015 to 21. They spent 5-6 years just to research how the world computer might look like. And that's when we saw in March 2021 the birth of the internet computer blockchain. Dominic William is the chief scientist behind this whole initiative and the idea, and is still a very, very active contributor to the whole ecosystem. Yeah, you can read more about ICP, Definitive Foundation, the researchers at the foundation, Dominic himself, via simple Google search. Thank you so much. And I'll open the forum for questions. Feel free to ask anything to me.
I got a question. I was reading in the news that some integration of OpenAI or artificial intelligence were going to be related with the ICP. I don't really quite understand how. Can you explain a little more of that? Thank you.
Yes. So, for example, today, if you want to have an AI integration within your application, what do you do basically? Essentially, you basically code few lines in Python smart contract, Python, and then essentially call OpenAI API if you want to use the large language model, right? Or if you are very, very tech savvy, probably you'll have a Llama 2 or Llama 2.c version of the smart contract, and you'll execute that on your processor in the servers or even graphic card at home. But that's the Web2 story, right? How do you bring AI capability to the internet computer blockchain? A very lame way would be, hey Ritvick, you told us about, calling HTTP calls from the smart contract itself. I'll call the OpenAI API. But that's a centralized way of invoking AI functionality. What if tomorrow OpenAI doesn't exist, they stop you or whatever? Right now, researchers at the foundation are working very hard to bring the AI capabilities on the blockchain itself. So what will happen is, using your smart contract, you can invoke certain functionalities of running inference model directly on chain. Right now, it's only supported with these powerful servers, which we have. So there is certain limitations. But the foundation is also working very hard to power these node machines which are sitting in the data centers with the more graphic computing power as well. So that way, if you want to invoke any inference engine, do any sort of machine learning or even complex AI-based calculations, you'll be able to do from within the smart contract itself. The alpha is out, and we are inviting applications. If you're passionate about creating something about AI, you can build that AI. You can show us the use case via leveraging OpenAI, and then you can come into the program and get some grants and build on top of it, you'll get early access to the beta functionalities, how to invoke AI from the smart contract itself.
I think we also have another question from Katrina.
Yeah, so the idea of ICP, the original inventor was Dominic William, as you saw, and he was very, very early in the ecosystem itself. So he was very close to the people who were working at the Ethereum Foundation. So let me give a story. So Charles Hoskinson, the founder of Cardano, Vitalik Buterin, and all the key stakeholders of the early blockchain, they all knew each other. Like they were knowing what efforts are being made in the blockchain industry. Many people were trying to solve the Bitcoin problem. So Dom had a different vision. Dom was thinking about a scalable blockchain. You can store data, and just apart from blockchain, he wanted to have a decentralized cloud itself. So that's the idea where he got an idea. There should be a world computer, which we have in the form of internet computer today, and it took many years, right? So asking about were there any problems, I'm pretty sure there would have been many problems. Ethereum came out in 2015, and nobody realized what Ethereum can do until 2021, till we saw Uniswap as an exchange, right? And imagine it went through a 6 years of period where Ethereum was only used as a exchange of value, similar to Bitcoin. And in terms of funding and everything, ICP is decentralized enough right now. But people who initially supported ICP, they poured in a lot of money in the order of $100 to $200 million. So big VCs like A16Z, Polychain Capital, many angel investors, they are the early investors in the ICP chain itself. And because of that fund, the foundation was under the research period for around 4 to 5 years, even before bringing out a initial version of internet computer, what we see today.
Thank you.
Any other questions?
I have a question while somebody types up their question, or we'll segue. Can students contribute with on the hardware side, or just on the coding and community development side?
Anybody is free to basically, join the internet computer blockchain in a node provider capacity. So we call them as node providers. But few things to keep in mind. These machines are very costly, on an order of $20,000 to $25,000 just for one machine. And it will be very hard for students to run just one machine in the data centers, because data centers usually have 3-year contracts, and you'll not get like your return on investment if you just run one machine, to be honest. You'll at least have to plan for like 3 to 4 machines, and that too you'll have to run in a geography where there are no internet computer nodes as of today. So as when I shown you the whole dashboard itself, there are not many nodes in the North American continent, in the Europe. But then let's say if somebody plans to put some nodes in Africa, left part of the Australia, or even in Latin America, those were the places where you can basically make your nodes profitable. Right now, the protocol is strictly focusing on Satoshi, the Nakamoto coefficient. So that has an equation like how distributed the nodes should be geographically, how distributed the ownership of the nodes should be, how distributed the data center for the nodes should be. So there is this whole calculation. So you can go onto forums and you'll find some threads over there, and then you can pick a geography and basically run those mathematical models, and you'll figure it out where it will be more beneficial for students or anybody to put nodes on the whole planet.
Just to jump in really quick, I think you mentioned the Nakamoto coefficient. That's just a new concept. That's new to me, so I was wondering if you could explain more on that? I'm
Yeah, I
just
think
really
you
trying to learn.
Yeah, Nakamoto coefficient was one of the equation, and even I haven't delved deep into it, like whether the actual Nakamoto created it or it was a function which came into existence after the birth of Bitcoin. But what it gives you is with a mathematical model, so consider it as a equation which can factor in multiple things. How many unique wallets people use to own the Bitcoin? What is the weighted distribution of that Bitcoin is, where the miners are basically. If the miners are just from the North American territory, the coefficient will be very, very less. If it is geographically distributed, the coefficient will be more. So coefficient gives you a degree of how decentralized the network is. And right now, these were the few parameters which I gave you right now. But imagine you are creating a different sort of blockchain. You create a blockchain just for the distribution of electricity. You might have more variables coming into this equation. The more variables you introduce, the goal of the Nakamoto coefficient is basically to achieve a higher degree number while satisfying all the individual verticals. So essentially, it gives you how decentralized a blockchain network is.
Thank you so much. Yeah.
I got a quick question in the chat. What do you think about the principal challenge for the implementation of EPC? And is this trying to replace the core internet service, or is just a complement?
Very good questions. So right now there are various challenges. So the biggest challenge for ICP right now is the adoption. Without any adoption, no matter how great the tech is, the tech will die, right? There have been many efforts in the past in our civilization. Great products fail if they don't have adoption there. So adoption is one of the greatest challenge. The another challenge is basically solving all these third-party chain integrations, which the ICP protocol has taken care of in order to basically, rather than competing with all these chains, though there is a lot many differentiating factor, the ability to build on the ICP itself. But since Ethereum is widely accepted, Bitcoin is widely accepted, ICP will have to give more and more functionalities to support other blockchains as well. And rather than being a Bitcoin killer, Ethereum killer, ICP, in my opinion, will be in existence alongside with at least these popular two chains. And you talked about whether it will replace our current internet. That's a story we'll probably hear later in the future. But the aim of internet computer is basically to make the internet more fairer, more transparent, and more autonomous. Most of the developers at the foundation, they have taken more than 8 years of pledge to support the development of this protocol, and the adoption will really see where we are. But it will not replace the internet, in my opinion, at least for next 20 to 30 years, because internet right now, as we see the TCP/IP layer, that's the blockchain. That's the backbone for even the internet computer nodes to function. So many providers might die. Many traditional companies might switch their models by migrating from traditional clouds to internet computer, but internet will still exist. And internet computer is something on top of it. It's a world computer built on our public internet itself. Among the differentiations in your company against other, what is your favorite and more advantageous in your opinion? The Bitcoin and the Ethereum integration, the ability to control other blockchains from ICP, that's a differentiating factor we have. The another good part is infinite amount of compute and storage, which you can do on the ICP chain that completely beats all the other layer one ledger-based technologies in the market. Which one of the coding language would you recommend using in this field? And why? Motoko and Rust? I would go with Motoko. It's the native language. So Motoko was designed keeping in mind how a developer would want to leverage all the cutting edge features of the internet computer blockchain. Since Rust is a open standard for WebAssembly, the support might be a little bit lagging. For example, you would want a Rust library to interact with Bitcoin blockchain. since the feature is being built on ICP, Motoko will have the first SDKs for it. And later on, the other languages like Rust, Python, and TypeScript will follow it. So I would strictly recommend Motoko. And it's not very hard to learn Motoko. You guys have learned C, C++, and even Java in your coursework. Motoko is exactly similar, playing with variables and data structures at a memory level. It's very, very similar to it. A very good question. How do we explore this DAOs and ICP web pages? Can we use a standard web browsers? Or no, you can, as I mentioned, right? So even if Google is seeing the smart contracts in the website, you can also interact with those DAOs, right? So let me give a quick example. If you go to sonic.000, it's a decentralized exchange built completely on the ICP. And you see, I just use my normal internet connection to open this. And also I can interact with the whole application itself in a decentralized manner. So these traditional domains in the background, they are interacting with the smart contracts, which are deployed on the internet computer blockchain. So if you see, there are certain queries being made here, and these are the queries which are talking to the internet computer canisters. That answers your first part. The second part is how do I explore DAOs? What you can do is you can go to Internet Computer, the main website, and then here, develop, use, learn. Sorry, not here. Okay. So on the dashboard itself, you see all these SNS here. We talked about service nervous system. These are all the DAOs which are already launched on the Internet Computer Blockchain. So OpenChat, Nuance, Usenet, these are all the essential DAOs. And if you go to the overview, you'll find more details about it, how the tokenomics look like, what the website is, what they are doing. So for example, if two of the friends would want to chat very, very privately from today, trash Telegram, trash Bitcoin, you can start using OpenChat. Very secure, happening via blockchain, and two people can directly interact with each other using OpenChat as a protocol. Yeah, so all the DAOs you can explore here. If you want to, also explore what all new DAOs are coming on to the Internet Computer Blockchain, here, please share this link, nns.ic0.app. You can go to Launchpad and see all the new projects which are going to launch on the chain itself, and all the projects who have launched in the past. So for example, if I go to a project like Hot or Not, it's a decentralized TikTok, how the DAO formation happened, right? And how many ICPs they raised around 1 million ICP, and this is around like $15 million as of today. They raised at $5 million valuation. You'll get to know and learn more about DAOs here on the NNS as well as on the dashboard itself. Any more questions?
I have one last question, and if no one has another question after me, then we have a tradition here to take a picture with our guest speaker. So we would like for you to hang on so that we can get everyone in front of the camera, in front of the TV, to take a picture with you. But one of the things that I find it fascinating about the Internet Computing Protocol is HTTPS and the difference of a canister smart contract opposed to a Solidity smart contract. If you could briefly give us that explanation about those key differentiating factors and what they allow, I think it would be very helpful for everyone.
Perfect. So imagine you have a smart contract on Ethereum blockchain. What it can do? It can only do two things. First is it can store the software code. And second thing, it can just execute the software code. And that software code is very, very local to what you call Ethereum virtual machine. Things can only happen within that virtual machine, right? So you cannot talk to the outside world. You do not understand anything else. You are just given a program, the input, and then you can only record output, and output will become part of the Ethereum ledger itself. If you give an image to that particular input, that input can be stored as an output, but that's a very, very costly affair, right? So on internet computer, through a smart contract, it's a virtualized environment. We call it canisters, but they have access to the outside world as well. So you can make HTTP calls to Yahoo Finance API, Google Weather API, or any traditional application you can think of. You can make calls to our traditional web and consume that data within the smart contract itself, which cannot be done on the other blockchain. This is one feature. The other feature is you can store enormous amount of video, image files, and whatever within that smart contract itself. We have seen the cost, right? Just $5 for 1 gigabyte of data for the whole year. So it's much cheaper. Essentially, you can use it to build a complete social network on the ICP blockchain itself. And there are a couple of already built, as we mentioned, Discover.one, the LinkedIn equivalent version. There are a couple of them which are under the development process, but that doesn't stop any developer to think of their own immutable, ever-existing social network if they want to create on the ICP blockchain.
I think we have a last question and then we'll go for a picture.
Are there any risks with staking ICP, like the possibility of losing the rewards, as this is possible with other applications? I'm not sure which other applications you're talking about. Like with Ethereum, if you store or stake, Ethereum, as long as the humans are not doing errors, most probably it's safe. We have seen a couple of bugs in MetaMask over the course of time. Since MetaMask is outside the protocol, that's where the bugs are introduced, right? The developers are continuously building and somebody can mess it up. Also based on email spoofing and the reckless behavior of the user. If you keep your funds in MetaMask, that is also not secured, right? You have to store it on your hardware wallet. As Binance, yes, so Binance is a centralized exchange. If you are a Web3 user, it should be a nightmare to store your funds in Binance or any centralized exchanges. The whole concept of Web3 and blockchain is you should own your private keys, not your keys, not your Bitcoin. A very famous phrase, right? So in the blockchain and crypto ecosystem, you have to have control of your own wallet. MetaMask, hardware wallets, these are the popular ones. For internet computer, you have to use internet identity or any browser-based wallet which is available, but never ever trust any of these centralized exchanges. They are very vulnerable to all the attacks, and even if the founding team or something goes wrong at the organization, you all have seen the classic case of FTX, right? Many people stored their funds on FTX, and because of the bad doings of a couple of group of people, immature people, most of the people lost their funds. So yeah, and staking on ICP, that happens through a cryptographic algorithm, so it's well secured there, as long as the user is not recklessly behaving and handling their private keys.
So thank you so much, Ritvick. Hold on, because we're all going to move to the front here to take a picture.